A satellite in a circular orbit very close to the surface of the planet with the speed v0. At some point, it is given an impulse along its direction of the motion, causing its velocity to increase n times or neta times. That is, its speed becomes n times of v0. Now the satellite goes in an elliptical orbit. The maximum possible value of your neta for satellite to move in the elliptical orbit will be equal to how much? You know that any planet which is been revolving around the Earth, like say this is your some planet or some satellite. The satellite is moving in a circular orbit with a velocity, say for example, v0. You know that what is the velocity of your satellite which has been revolving in the circular orbit? Orbital velocity. Orbital velocity formula వచ్చేసి v0 is equals to under root of g into r. Small g ఏంటంటే small g is equals to your capital G, capital M divided by your r. So here r, it is going from a certain height. Here to here, this is the radius. And here to here, this is your height h. This r plus h is nothing but small r. So this is r plus h. So I can take this one also here, r plus of your h. That means this value will become for me g into your whole square. So it is g into your m divided by small r square. So orbital velocity will become for me under root of your, this is capital G, capital M divided by r. And r plus h, r plus h. R I am taking this one.
Yes, sir.
Now what is telling is satellite in a circular orbit very close to the surface of a planet with speed v0. At some point it is given an impulse along its direction of motion, causing its velocity to increase neta times. అంటే అది ఇంపల్స్ ఇవ్వకముందు it was moving in a circular కాబట్టి orbital velocity. ఇంపల్స్ ఇవ్వగానే ఏమైపోతుంది, satellite will enter into the space అంటే అప్పుడు దానికి escape velocity వచ్చేస్తుంది. Escape velocity will be equal to under root of your 2 times of capital G, capital M divided by your r. But tell me escape velocity will be equal to how much for me? Gm by r is nothing but orbital velocity. So it is root 2 times of your orbital velocity. Isn't it? So I can say that when your neta is lesser than or equal to root 2. Isn't it?
Yes, sir.
Isn't it? Because speed is becoming for me how much for me? N times of your v0.
Yes, sir.
So otherwise the satellite will escape from the gravitational planet and it will enter into the space particulation. So what is the answer I can write for this one? N must be lesser than or equal to root 2. Root 2 ki takva value, root 2 value is nothing but of your 1.4. This one is nothing but of your 2. So what I can write the answer?
Option D.
Option? ఇది root 2 plus 1 ఎక్కువైపోతుంది.
BB.
It should be equal or lesser than kada. So fourth option పెట్టుకో.
Yes, sir.
Okay na? Sure. Next question ఉన్నాను. Question number 7. So chadu. Figure shows the capillary tube in which the liquid rises to a height h. Now if the air is blown through an horizontal pipe in the direction of the arrow, అంటే ఇక్కడ నుంచి, then the liquid height in the capillary tube will be equal to how much? So చూడు ఎంత అవుతుంది?
Decrease అవుతుంది. Same అవుతుంది, sir.
No, when the air is blown through this horizontal tube, what is happening? The pressure on the top of the liquid will decrease. ఇక్కడ ప్రెషర్ తగ్గిపోతుంది. ఇక్కడ ప్రెషర్ తగ్గడం వల్ల ఏమైపోతుంది? లిక్విడ్ విల్ రైజ్ ఫ్రమ్ ద క్యాపిలరీ ట్యూబ్. సో ఇట్ విల్ ట్రై టు రైజ్.
సార్ ప్రెషర్ తక్కువ ఎందుకు అవుతుంది అక్కడ?
సో ఇక్కడ ప్రెషర్ తక్కువైపోతుంది కదా. బికాస్ ఆఫ్ దట్ వన్ ఇట్ విల్ ట్రై టు ఆక్యుపై అండ్ గో ఇన్ ద అప్వర్డ్ డైరెక్షన్. సో అప్పుడు ఏమైపోతుంది? హైట్ విల్ బి గ్రేటర్ దాన్ హెచ్. ఓకే
సార్ అక్కడ ప్రెషర్ డిక్రీజ్ ఎందుకు అవుతుంది అర్థం అవుతుంది.
ఎందుకంటే ఇక్కడ ఆల్రెడీ ఎయిర్ మాలిక్యూల్స్ ఉన్నాయి కదా. ఇక్కడ నువ్వు ప్రెషర్ అప్లై చేయగానే ఈ ఎయిర్ మాలిక్యూల్స్ మొత్తం ఇట్లా వెళ్ళిపోతున్నాయి. ఇక్కడ వాక్యూమ్ క్రియేట్ అయిపోతుంది. అండ్ ఆ వాక్యూమ్ క్రియేట్ అవ్వగానే ఇక్కడ ఉన్న ఎయిర్ మాలిక్యూల్స్ ఏమైపోతాయి? పైకి రావడానికి ట్రై చేస్తాయి. బికాస్ ఇస్ ఎగ్జర్టింగ్ ద ఫోర్స్. వాక్యూమ్ కదా, ఇక్కడ ఏం ప్రెషర్ లేదు. ఇంతకుముందు ప్రెషర్ ఉండే కాబట్టి ఇక్కడ వరకు ఉండే. ఇప్పుడు ఈ ప్రెషర్ వెళ్ళిపోగానే ఏమైపోతుంది? ఇట్ ఈస్ ఫ్రీ టు మూవ్ ఇన్ అప్వర్డ్ డైరెక్షన్ కదా. సో అప్పుడు ఏమైపోతుంది? దిస్ వాటర్ మాలిక్యూల్ విల్ ట్రై టు మూవ్ ఇన్ ది అప్వర్డ్ డైరెక్షన్.
yes sir.
ఓకేనా? చలో.
Yes,
greater than of your h. Then question number 8. The following indicator diagram, ratio of work done in the process 1 to that of your process 2. Basa chudu. Process 1 is in which direction beta? This one is your clockwise. Process 2 is your anti-clockwise. Isn't it? And you know that work done in the clockwise direction will always be your positive. Isn't it?
Yes, sir.
And work done in the anti-clockwise direction will be your negative. What is asking is what is the work done in the process 1 to that one. So radius of the first one is r, second one is nothing but of your 1.1. And I can write the work done for the first one is nothing but equal to how much will be? Work done will be equal to your area under the curve.
Yes, sir.
Area of this one will be equal to pi into your r square. W1. W2 will be equal to area of this one. So it will be your negative minus pi into your 1.5 into your r whole square. Ante kada area under this circle will give me the work done. PV graph kada. So it's asking the ratio of this work done. So W1 divided by W2 will be equal to pi into r square divided by minus of your pi 1.5 means 3 by 2. 3 means 9 into r square divided by 4. Ante kada e pi e r square will get cancelled. So obviously it will be minus of your 4 by 9. Minus 4 by 9. Good question. Choose ko sir. Ante kada?
Yes,
Work done
sir.
is always equals to what beta? Area under your PV graph. So I have taken here area of circle for the first one, area of the circle for second one. Work done for the clockwise direction is positive, anti-clockwise direction is negative. Antena?
Yes, sir. Yes, sir.
Sure, great. Question number 9. Formula gurtundala. Mean free path of oxygen molecule at your 0 degree centigrade and pressure P is lambda 1 is equals to 9.5 into 10 power minus 8 meter. Keeping the temperature constant, pressure is reduced 100 times. The new mean free path will be equal to your how much? Mean free path formula gurtunda. Mean free path in the kinetic theory of gas is given by the formula
Root
lambda is
square
equals to
root of
1 by root 2 pi into your n into your d square.
yes,
Isn't
sir.
it? Where is the n? N is nothing but of your number of molecules per your unit volume. That will be equal to your P divided by your Boltzmann's constant into T from the kinetic theory of gases. PV is equals to your N into K. Number of moles कहते हैं रासम हम PV is equals to nRT. Molecules कहते हैं रासम PV is equals to your N into your K into T. गुर्तुंदा.
Yes, sir.
So N value will be equal to your capital N divided by V kabatti. So capital N divided by V will be equal to how much? We got to choose, isn't it? So capital N divided by your V. N on the V on that. This is P by your KT will be equal to your N by V from the ideal gas equation. A value could assess. So I got the value of your N right now.
Yes,
Isn't it?
sir.
So in terms of pressure, man mean free path వచ్చేసింది కాబట్టి lambda is equals to your 1 divided by this one is root 2 into pi. N value will be equal to P. This will go up, bulk modulus will be upward, temperature T. This will be equal to your here also capital T. Antena?
Yes, sir.
Boltzmann's constant will be equal to your root of 2 pi. This will be P in the place of N, P, KPT, and this will be your D square here. So, and the other P value astronomy, E plus of N, E value Russian. P divided by Boltzmann's constant into your T. What is the relation? Is asking us mean free path of oxygen molecule at 0 degree centigrade and pressure pressure is lambda 1. So lambda 1 is given in terms of your pressure. Keeping the temperature constant, pressure is reduced to 100 times. That means what is the relation between the pressure and wavelength beta? Inversely proportional.
Inversely proportional.
So I can write here lambda 2 divided by lambda 1 will be equal to P1 divided by P2.
Yes,
So
sir.
I can write here lambda 2 is equals to your, this one is lambda 1 into your P1 divided by P2.
Yes, sir.
P1 ఎంత ఇచ్చాడు మనకు ప్రాబ్లం లో?
Ratio 100 times ఇచ్చింది.
Ratio is given for me as 100 times. Lambda 1 ఎంత ఇచ్చాడు?
9.5 to 10 raised to minus 8.
9.5 into 10 power minus of your 8 into this one is your P1. P2 is given how much for me? Reduced by 100 times. And P2 will become for me P1 divided by 100. ఈ P1 వెళ్ళిపోతుంది. So that will be equal to 9.5 into 10 to the power of minus 8 into 100.
Minus 6.
ఎంత అవుతుంది? 6. 6 ఎక్కడ ఉంది దీంట్లో? థర్డ్ ఆప్షన్.
Third option.
అంతేనా?
Yes, sir.
నెక్స్ట్ వన్ ఇస్ ఎలక్ట్రోమాగ్నెటిక్ వేవ్స్. ఇది నువ్వు ట్రై చేయి ఒకసారి. దెన్ క్వశ్చన్ నెంబర్ 11 చూడండి. క్వశ్చన్ నెంబర్ 11 ఇస్ అగైన్ వెరీ గుడ్ క్వశ్చన్. ఒకసారి ట్రై చేది. Given below is a graph between ln dn by dt, y-axis ln dy by dx, and this is your t, isn't it? And from the graph, half-life of the radioactive sample will be equal to how much? We know the formula in radioactivity, n is equals to n naught exponential to the power of minus lambda into t,
Yes,
isn't
sir.
it? So dn divided by your dt will be equal to your n naught exponential to the power of minus lambda into your t, isn't it? Into this will become how much for me? Minus of lambda. Activity. A is equals to your lambda into your n. Another. A ante dn by dt. N ante n naught exponential to the power of minus lambda into t. And decay constant is right now this graph is decreasing. That is the reason I'm taking there as a negative. So if I take the magnitude of this one, mod of your dn divided by your dt will be equal to lambda into n naught exponential to the power of minus lambda into t. Then now take the
Yes,
log for
sir.
this one. This is a ln of your dn divided by your dt is equals to your ln of your, this will become for me lambda into your n naught minus lambda into t. Antena?
Yes, sir.
Log. Isn't it? Now compare with the straight line equation. Y is equals to your minus of m into your x plus of your c. So in the given condition, what is the value of your y beta?
The time.
dn by
Sorry,
dt.
dm by dt.
dn by
Log
dt
of
is how much for me? Or 8. అంతే కదా.
Yes, sir.
Ln dn by dt is nothing but equal to y-axis పైన ఎంత ఉంది 8. This is your ln lambda into your n naught minus lambda into it. What time beta? What time it is becoming 8? 2 seconds. So it is your into 2. Then come to the 4. So here I'm writing for this 4, the time is nothing but 6. That means this will be equal to your 4 is equals to your ln of your lambda into your n naught is equals to minus lambda into your 6. Isn't it?
Yes, sir.
This is my equation number 1. This is my equation number 2. See from 1 into what I can write. 4 ones are 4 twos are lambda naught will get cancelled. So I can get the value of lambda. So lambda value is coming out to be 1. If lambda value is 1, t half will be equal to how much better? T half is equals to ln 2 divided by lambda.
Yes, sir.
So this will be equal to ln 2. Second option.
Yes, sir.
So చూసుకొని ఎన్ని చేశాను direct formula n is equals to n naught exponential to the power of minus lambda into 2. I differentiated with respect to time. I got dn by dt. So once I have written the dn by dt, I have taken the log on both the sides and comparing with the straight line equation. From the straight line equation, I have got a 2 seconds dn log dn by dt value is 8, and at 6 seconds the ln dn by dt value is 4. Just take the ratio of that one, we'll get the decay constants. Once we get the decay constant, then use the formula t half is equals to ln 2 divided by lambda. The answer will be equal to your lambda value is given as equals to how much? 1. So it is ln 2.
Yes, sir.
Sure. Question number 12. Jordan. The current gain of a transistor in the common emitter configuration is 70. If the emitter current is 8.8 milliamperes, collector and base currents are respectively how much? This is what type of configuration beta? Common emitter configuration. That means beta. So beta is equals to your output current divided by input current. Output current will be collector, input current will be the base. And the problem
Yes,
is given that the current gain, that means IC is equals to 70 times of your base current. And you know that base current is always equals to your collector current plus of your base, emitter current. Emitter current is equals to collector current plus base current, isn't it? So I can write
Yes,
from this
sir.
one, IE is equals to, IC value is 70 times of your IB divided by IB plus IB, isn't it? So this will be equal to how much? This IB will get cancelled. So 70 plus of your 1. 70 times of your IB gather. 70 times of your IB will not get cancelled. Yes. Emitter current is equals to IC plus IB. So this emitter current will be equal to IC is 70 times of your base current plus this one is base current. That means this will become for me 71 times of your base current, isn't it? That means base current will be equal to your how much beta? IE divided by 71. Antena?
Yes, sir.
Now, what is asking the problem for me? If the emitter current is 8.8, that means this is 8.8 divided by 71. The collector and base current will be equal to how much? Collector current is 70 times of base current. So this will be equal to your 70 into your 8.8 divided by 71. Antena? So that will give
Yes,
me the
sir.
collector current.
Yes, sir.
Okay, 70 is 71. Approximately collector current. Collector current 1 point ఇది రాదు ఆల్మోస్ట్ ఇదే వస్తుంది ఎందుకంటే 70 తీసేసినా కూడా 8.8 సో 8.8 లో మనకు ఓన్లీ ఆప్షన్ మ్యాచింగ్ ఇస్ నథింగ్ బట్ థర్డ్ ఆప్షన్ అంతే కదా
Yes, sir.
ఎమిటర్ కరెంట్ ఈస్ మిలే ద కలెక్టర్ కరెంట్ అండ్ బేస్ కరెంట్ ఇప్పుడు నాకు ఎంత వచ్చింది కలెక్టర్ కరెంట్ ఎంత వచ్చింది రైట్ నౌ ఫర్ మీ 8.8 బేస్ కరెంట్ ఎంత వస్తుంది అన్న base current due to 8.8 divided by 71.
Yes, sir.
ఎంత వస్తుంది చూడు 8.8 divided by 71 ఎంత ఉంది 1/124 milliamperes approximately for option.
Yes, sir.
Okay.
Yes, sir.
Question number 13. If a carrier wave of amplitude 10 millivolt is modulated by an audio signal of amplitude 2 millivolt, then amplitude of the lower side band will be equal to how much? You know that amplitude lower side band and upper side band will be equal to how much beta? Amplitude of lower side band and upper side band will be equal to your, this is mu times of your AC divided by 2.
Yes, sir.
So, this ratio of your modulator divided by your AC into your AC divided by 2. AC will get cancelled. So the formula is AM divided by 2. Amplitude of modulating wave divided by 2. And the problem is telling that if a carrier wave of amplitude 10 millivolt is modulated when audio signal of your amplitude 2 millivolt, then the amplitude of lower side band will be equal to how much? This is the amplitude of what? Carrier. This is the amplitude of what? Audio signal. That means modulating signal. How much it is? 2 millivolts. So, 2 millivolt divided by 2.
Yes, sir.
And 1 millivolt.
Yes, sir.
This is the formula for mu beta. Lower side band, upper side band formula in the mu into your AC divided by 2. Mu is referred. What is mu is nothing but your index of your modulating divided by carrier wave. Carrier gets cancelled. So the answer is here AM divided by 2. Clear?
Yes, sir.
దాని తర్వాత చలో 18th one చూడండి YDSC question. In YDSC, if the maximum intensity is I naught, then what is the intensity at a point where optical path difference between the waves coming from the two slits is lambda by 4? Intensity formula చెప్పు ఒకసారి I is equals to your, this will be equal to your I1 plus I2 plus 2 times of your root I1 I2 into your cos of your phi. Anna?
Yes, sir.
Intensity. Phase difference is calculated by the formula delta phi is equals to 2 pi by lambda into your path difference. Given in the problem is that if maximum intensity is I naught, isn't it? Then what is the intensity at a point where optical path difference between the two waves is coming out from your lambda by 4? Ante delta x ichadu. Delta x is given. This value is nothing but for me what? Delta x. So path difference enta vastundi chudu. So delta phi is equals to 2 pi by lambda into delta x is equals to lambda by 4. This one get cancelled. 2 1s are 2 2s are. That means this one is nothing but equal to how much? 1 by 2. So delta phi value 1 by 2 on the and intensity is here given is how much for me? I1 and I2 value is equals to your I naught. Isn't it? So I value enta vastundi chudu ippudu. I is equals to your, this value will become for me I naught plus of your I naught plus 2 under root of your I naught into I naught square into your cos of your, this one is 1 by 2. అంటే 5 వాల్యూ ఎంత వస్తుంది 1/2. 5 వాల్యూ 1/2 వచ్చిందంటే what is the value beta? For what value it is 1/2? Pi by 2 is it 1/2 also. This is pi by 2. So pi by 2 ante 180 divided by 2 90. Cos 90 will become 0. ఇది మొత్తం 0 అయిపోతుంది.
Yes, sir. 0 అవుతుంది.
అంటే this will become for me 2 times of I naught.
Yes, sir.
What is asking if the maximum intensity is I naught, then what is the intensity at a point? అంటే I naught will become for me or I divided by 2. అంటే third option.
Yes,
Okay,
sir.
19th one చూడండి. Potentiometer. Potentiometer has a wire of 8 meter and the resistance of the wire is 20 meter. అంటే ఇది potentiometer wire. దీని లెంత్ ఎంత ఇచ్చాడు మనకు 8 meters. Resistance of the potentiometer wire ఎంత ఇచ్చాడు 20 ohms. It is connected in series with a cell of 2 volt and internal resistance of 2 ohm and a rheostat. అంటే ఇక్కడ somewhere ఒక cell, internal resistance and rheostat. And a rheostat, find the value of the resistance in the rheostat when the potential drop along the wire is 20. Okay, this is connected to some galvanometer in this rheostat and somewhere here connection. EMF is the internal resistance R. Clear?
Yes, sir.
Length is given 8 meter, resistance is given 20 ohms, EMF is given for me 2 volts, and internal resistance is given as of here 2. So I can calculate first potential gradient. Potential gradient means what is the potential for your unit length. So that is your 20 into your 10 to the power of your -6 divided by microvolts divided by length. Length is given how much for me right now in this one? Per meter, per meter. Isn't it? The value of resistance in the rheostat with the potential drop along the wire is 20 micrometer per mm. That means 10 to the power of your -3. And then 20 into 10 to the power of -3. Isn't it?
Yes, sir.
But in the problem to find the value of resistance of rheostat. Dini yokka resistance enta ani adugutunna. So we know the formula, potential gradient V by L is equals to your I into your rho. So current will be equal to how much for me? Total EMF divided by total resistance. Capital R plus small r plus of your resistance of your potentiometer wire into your rho. Rho value is nothing but equal to your R by your L. Isn't it? So V by L value already man daggara undi. I is nothing but total EMF by total resistance into your R. This is your potentiometer wire resistance per your unit length. So everything I got right in this one, I can calculate the value of your rheostat. This one is your rheostat value. So V by L value, I'm writing here somewhere. This one I'm writing here. 20 into 10 power -3 is equals to EMF is given how much for me? 2 volts divided by, and this one is given by resistance is 20. And internal resistance is how much for me? 2. 20 plus 2, that will be equal to 22 plus resistance of your rheostat. And then into your capital R is nothing but equal to your 20 ohms and the length of the wire is nothing but of your 8. Isn't it?
Yes, sir.
So 20 into 10 power -3 is equals to, this will be 40 divided by 22 plus of your RH into your 8. And then?
Yes, sir.
8 ones are?
5, sir.
10 power -3 is equals to 5 divided by 22 plus of your RH. So 22 plus of your RH will be equal to 5 divided by 20 into 10 power -3. So that will be equal to 500 divided by 2. That means this is 250. So resistance of rheostat will be equal to 250 minus 22. 250 minus 22 is 228 ohms. So it should be 228 ohm. Got it? Direct formula based question.
Yes, sir.
Then the question number 24. See the question number 24, beta. De Broglie wavelength associated with a proton changes by 0.2% if its momentum is changed by P naught. Initial momentum was n times of P naught, then value of n will be equal to how much? De Broglie wavelength formula, lambda is equals to your h divided by your momentum. Isn't it? Percentage lecture but I can write this one as delta lambda by lambda into your 100 is equals to your minus of your delta P by P into your 100. The H is right now for me a constant. So this value is given as 0.25 is equals to your P naught divided by P into your 100. So I can write the value of P right now. So P value will be equal to your, this one is P naught divided by 0.25 into your 100. 0.25 into ఎంత? This is 100 times of P naught divided by 1 by 4. Antena? This will
Yes,
become
sir.
for me 400 times of P naught.
Yes, sir.
Isn't it? So what will be the answer? The initial momentum was n times of P naught. N times of your P naught. Until 400. N value will become for me how much? 400. Got it?
Yes, sir.
Sure. Next one. The stopping potential for a photosensitive metal corresponding to a certain wavelength lambda of radiation 4.8 volt. Upon doubling the wavelength, the new stopping potential is 1.6 volt. Isn't it? The threshold wavelength for the metal is found to be n lambda. Find the value of your N. Einstein's photoelectric equation chapter sorry. E is equals to work function plus stopping potential.
Yes, sir.
Mana?
Yes, sir.
So stopping potential sorry. E into V naught by discussion. E into V naught will be equal to your. This will be equal to your how much your work function. This will be your energy. This is your E minus of your work function. Antena?
Yes, sir.
So the stopping potential until this is V naught is equals to your E by your E minus work function divided by E.
Yes, sir.
Energy can be written as V naught is equals to your E is equals to your HC by lambda into your E minus work function divided by your E. Okay,
Yes, sir.
now this is the formula. So I'm ultimately getting stopping potential formula. V naught is equals to H by E constant into C by your lambda minus work function divided by E. Now write this one for the given problem. What about first one? The stopping potential for a photosensitive metal corresponding to a certain wavelength of lambda radiation is 4.8. And this one is 4.8 volt is equals to H by E into your C by lambda minus work function divided by your E. Inko daniki enta undi 1.6. So it is 1.6 into V is equals to your H by E into your C by, after wavelength is found to be or how much right now? And doubling the wavelength and this one is a 2 lambda minus of your work function divided by E. The threshold wavelength of the metal is found to be n times of your lambda. Antena?
Yes, sir.
Two equations solved. Equation 1, this one is equation 2. What you can do is subtract 2 from your 1. So it is 4.8 minus 3. That is 3.2 volt. That is equals to H by E into C by 2 lambda because remaining will get cancelled anyhow. So from this one I can write work function value will be equal to how much better? H by E divided by C by 2 lambda is 3.2. Substitute this value in this one. So it is 1.6 volt is equals to 3.2 volt is minus of work function divided by E. And the work function in work function divided by E value will be equal to 3.2 minus 1.6 and 1.6 volt.
Yes, sir.
Now work function and I can write in terms of threshold wavelength HC divided by E into lambda naught. Lambda naught is a threshold wavelength. is equals to 1.6 volt.
Yes, sir.
So HC by E into lambda naught. You can compare with this one, but I'll take this equation 3. I'll take equation 4. So from 3 and 4, see what I can get. E3, E4 nunchi. HC by E. HC by your E. Isn't it? So I can just compare with both of them. Student doesn't run it comparison.
Yes, sir.
So rondity comparison, HC by V is equals to HC divided by your E. HC by your E. Okay, what I can do is I'll just write with other pen, you'll get a clarity. So I'm substituting 4 in equation number 3. So substituting 4 from 3 and 4, I can write 3.2 is equals to HC divided by E. HC divided by your E. I can write as 1.6 into lambda. 1.6 into your lambda naught divided by 2 lambda.
Yes, sir.
This is ones, this is twos.
Yes, sir.
So lambda naught will become how much for me? Lambda naught will become for me 2 into 2, 4. 4 lambda.
Yes, sir.
And n value will become for me how much? 4. Good question, bro. Practice your questions.
Yes, sir.
The question number 30. 30 is right now for me over damped oscillations questions. The amplitude of a damped oscillator becomes half in 1 minute. The amplitude after 3 minutes will become 1 by x times the original value. Find the value of your x. Damped oscillation formula A is equals to your A naught exponential to the power of minus lambda into t, where lambda is nothing but what beta for me or constant, and t is nothing but time. For what time is asking beta? The amplitude of a damped oscillator becomes half in 1 minute. That means t is equals to your 1 minute. A value is becoming how much for me? Half. That means A naught divided by 2 is equals to your A naught exponential to the power of minus lambda into t is nothing but 1. Isn't it? So this A naught, this A naught will get cancelled. So this is exponential to the power of lambda is equals to 2. Then for 3 minutes, how much it is? For 3 minutes, I can write again same formula. A is equals to A naught exponential to the power of minus lambda into your 3. Isn't it?
Yes.
So simplify this one. How much I will be getting, you see? This value will become for me A naught divided by, this will become for me exponential lambda to the power of 3 and square. Exponential to the power of lambda value already I got 2. So it is your A naught divided by 2 power 3. So 2 power 3 and 10,000. A naught divided by 8.
Yes, sir.
Now the problem is telling that after 3 minutes, it is becoming 1 by x times. That means x will be equal to how much? 8.
Yes, sir.
Okay, so total any question chesam manam 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 questions in your how much minutes? 30 minutes in the 20, 30, 40 minutes. 12 questions, 12 fours are
48.
48 marks వస్తుంది. అది నేను ఎక్స్ప్లెయిన్ చేసినాను కాబట్టి కొంచెం వెళ్ళిపోయినాయి. You can still try to do some problems which you can try to do on your own.
Second question, sir.
Third question, second questions ఇలాంటివి చేయొచ్చు ఒకసారి.
Yes, sir.
Question number 2 కూడా ట్రై చేసుకోవచ్చు. ఆల్రెడీ ఎగ్జామ్ లో వచ్చిన క్వశ్చన్ సార్, PYQ క్వశ్చన్ సార్, ట్రై చేయాలి. ఓకేనా?
Yes, sir.
అంటే ఎప్పుడు క్వశ్చన్ పేపర్ వచ్చినా కూడా యూ నీడ్ టు అట్లీస్ట్ టిక్ సమ్ క్వశ్చన్స్. 12 to 15 questions and tick chesesకొని minimum ga you need to do without negative marking in this one. So there are so many questions which are directly formula based, isn't it? Today the sixth one was a formula based, seventh one was a direct question. Question
Yes,
number
sir.
8 was also directly formula based question. Only question చదివి మనం ఆ దీంతో చేయగలుగుతాం. Question number 9 is also a formula based. ఈ ఫార్ములా టైంలో గుర్తు రావాలి మనకు. మీన్ ఫ్రీ పాత్ అంటే లాంబ్డా అని ప్రెజర్లో రాయాలా, ఇలాంటివన్నీ గుర్తుండాలి ఖచ్చితంగా. Question number 11th one is directly మనని రివిజన్ చేసాం ఇది మనము. Question number 12th one is also direct question. 13th one is also direct question. I think we can even do question number 14 try చేసుకోవచ్చు నువ్వు. Question number 17 కూడా చేయొచ్చు డైరెక్ట్ గా ఒకవేళ ఏసీ కనుక రివైజ్ చేయగలిగితే. ఓకేనా?
Yes, sir.
So in this paper you are getting a score of your how much? 48 marks. On a rough.
Yes, sir.
నేను నీకు ఈరోజు ఇంకో పేపర్ పంపిస్తున్నాను. నీ అంతకు నువ్వు ఒక 1 hour టైం స్లాట్ పెట్టుకొని దానికి చెయ్యి. ఎన్నైతే అన్ని చేయి, రిమైనింగ్ ఐ ట్రై టు డిస్కస్ ఇన్ ద క్లాస్ ఫర్ యూ.
Yes, sir.
ఓకేనా?
Yes, sir.
పంపించాను చూడు ఒకసారి.
1 minute, sir. Yes, sir. పంపించండి.
ఓకే. సో ఆ క్వశ్చన్ పేపర్ లో మొత్తం సిలబస్ పైన ఉంది కాబట్టి సో ట్రై టు రీడ్ ద క్వశ్చన్ అండ్ ట్రై టు సెలెక్ట్ ఫర్ 10 to 15 questions first and try to do that one in the 1 hour and let me know if there are any doubts in this one. We'll try to discuss. Paper కొంచెం
Yes, sir.
lengthy ఉంది. So దాంట్లో 10 questions 8 questions select చేసి చూడు. When you feel that paper is tough, at least try to see that you try to do 8 to 10 questions without negative marking.
Yes, sir.
ఓకే, టఫ్ ఉన్నప్పుడు మాత్రం అందరికి టఫ్ అవుతుంది కాబట్టి యూ నీడ్ టు బి స్మార్ట్ ఇనఫ్ ఎట్ ద టైమ్. You need to try to select only the questions where you don't do any negative marking in this one.
Yes, sir.
ఓకేనా?
Yes, sir.
కొంచెం మార్నింగ్ తొందర లేనా 5 o'clock కి, ఎందుకంటే నాకు కాలేజ్ కూడా వెళ్ళాల్సి ఉంటుంది.
Okay, sir.
ఓకేనా?
Yes, sir.